Okay, today's section is all about distance. Okay, and I want you to look up at our agenda board. We're gonna go through distance today. Tomorrow we're gonna do an activity in class, and then you're gonna have your first graded assignment. I know. Okay, so it'll be your first grade in the grade book. Okay, so distance. Go ahead and draw a line for me here. And put 2 points on the line. Okay. When we talk about distance in geometry, we are talking about the length of a segment between 2 points. Okay. So, looking at our picture, I'm going to be asking you to find the measure of segment AB, okay? The distance between A and B would be the length of that segment, okay? So we're going to do two things today. We are going to find the distance between 2 points on a number line. We are going to find the distance between 2 points in the coordinate plane. Okay, so let's look at example 1. Okay, we can count, right? Okay, what is the length of segment CF? Okay, if somebody was confused about how you got that, besides counting 1, 2, 3, 4, 5, 6, how else could you get that measurement?
Subtracting the higher number by the lower number.
Okay, distance is going to be endpoint on the right minus endpoint on the left. Okay, but distance is always positive, right? Okay. We don't have negative distance. That's why we throw an absolute value there. Because what does the absolute value mean?
Like always positive.
Just like my shirt said yesterday, right?
Mm-hmm.
Did you notice my shirt yesterday?
I did.
It said, stay positive with an absolute value on it. Ooh, roasted. All right. What is the measurement of AD? Oh, it's also 6?
Yeah.
Because we would take 2 minus negative 4. Okay? So the distance between C and F is the same as the distance between A and D. So if we wanted to, we could say, oh, hey, CF is congruent to AD. Okay, so my husband also is a math teacher, right? And he has taught geometry most of his career. Like, this is his 17th year teaching, and he's taught geometry for most of those 17 years. And when I told him about the mustache thing from yesterday, he was like, I have never heard anybody say that. So he thought that that was pretty great. Aaron, you were the one that said that, weren't you?
Yeah.
Yeah.
Surprised he hasn't heard about that. It looks similar to a mustache.
All right, everybody. What is the length of CE?
4.
Okay, show your work and answer this question. I guess not show your work, but like at least like CB equals DF equals. Example 2, sorry. Bless you. Corbin, what's the length of CB?
2.
Okay. Jay, what is the length of DF?
3.
Oh, sad. Okay. CB is not congruent to DF. Is, you okay with that symbol? Not congruent? Kind of like not equal, but... I don't know. Because if I do this, it might link.
Why is it slash like that?
Because it's not.
Yeah, but why is that slash at that angle? I usually see it go from top left to bottom right.
Did I just not get it at a good enough angle for you?
No, it's fine. I just usually see.
Is that better?
Yeah.
Okay. All right. In example 3, when I copy and pasted this problem in, I did not get our QR and ST congruent. Okay. Is it okay that we don't have a number line on this problem?
Yeah.
I think this is a problem where we're okay not having a picture, okay? That doesn't happen very often, okay? What is the distance between Q and R?
19, and then it's
Okay, Samuel, how did you get 19? Okay, so can you talk me through that?
You put both in the absolute value, but the 12 first, because it's bigger, and then minus the
Okay, so 12 minus negative 7 is 19. Okay, and what about ST?
19.
If we take 16 minus negative 3, we also get 19. So what's the answer to our question?
Yes.
Yes. Okay. We can handle that, right? Okay. Now, when it gets really exciting is when we get to find the distance between 2 points on a coordinate plane. Go ahead and turn the page. All right. When I see this, I look at it and I see a hypotenuse. A hypotenuse is a part of what kind of a triangle? Could you please draw it to be a right triangle?
and the hypotenuse is the longest side.
Yes, Aaron, the hypotenuse is the longest side and always across from the right angle. We're actually going to do a lot with right triangles during second semester. Trigonometry is the study of triangles, and we're really going to get into right triangles. Yes.
Could you say the hypotenuse? Like
Hypotenuse.
hypotenuse.
Did you guys see my hypotenuse sticker?
Oh!
Seal.
It's a hippo. It's definitely a hippo. Okay. Now, who can raise their hand and tell me the Pythagorean theorem? She was reading my mind. Okay. So if we have sides A, B, and hypotenuse C, A squared plus B squared equals C squared. Okay? Now, P and Q are coordinates in our coordinate plane. Okay. So I'm going to call P coordinate x1, y1. And I'm going to call Q coordinate x2, y2. The 1 and the 2, they're just little subscripts that are saying, hey, this is coordinate number 1 and this is coordinate number 2. Okay. Now, A is this side right here. How do you suppose I find how long A is? Charles? Oh, yeah. A is just x2 minus x1. Because it's the horizontal distance, so we only care about the difference in the x's. What? So like this is x1, x2 along the x-axis, right? And then we go up to the y's. So if I'm curious about how long this is, I would just subtract the x's. Now, how would I find B's length? Okay, B would just be the difference of the y's. Okay, so instead of A, there is one right here, and there is one by the turn-in drawers. Okay, are you okay with what I replaced A and B with?
Yeah.
Okay, now, I am going to replace C with the letter D. Why do you suppose I'm going to do that? D for distance, okay? And if I have D squared equals something, how do I get rid of the square? We square root both sides. So D is the square root of
Oh my god, that's a pretty big formula.
Here's the deal. This is how the formula comes to be, okay? The distance formula is just an application of the Pythagorean theorem, okay? When I ask you to find distance, the distance formula is the square root of our x's subtracted squared plus our y's subtracted squared. And that's it. Have you seen this formula before?
It looks familiar.
I feel like you did it in algebra last year. Wait, did you? I actually don't. I don't think you've seen it. Well, I don't think you have. Right, I don't think you did distance formula. Nope. And really,
Alex remembered bringing it up and she said, not now.
you know what? That sounds like something she would say. Correct. Okay. Now, let's practice using it. Okay? So we're going to go to example 4. Okay. So this would be a suggestion I have for you. I am going to label x1, y1, x2, y2, just to help me out, okay?
What does the 1 and 2 matter?
It actually will not because we're squaring it. So whether I take 3 minus negative 2 or negative 2 minus 3, both of those squared will get us the same thing. So it doesn't matter who's the first coordinate versus the second coordinate. As long as we're consistent, we're going to be okay. So I'm going to take 3 minus negative 2 squared. That's my x minus x squared. And then I'm going to take my y minus y squared. Okay, so I took x here and y here. Okay, what is 3 minus negative 2? Okay, so are you cool if I write 25 right there?
Yep.
Okay, and 7 minus 5?
2.
Okay, so squared would be 4. So our distance, I'm just going to have you leave it as the square root of 29. Why would it not be 29?
It's not a perfect square.
Oh yeah, I know. Can't you like before that? Can't you like make the 25 a 5 on the outside?
Nope. You can only do that with multiplication and division. Okay? Square root of 29 is very different than 5 plus 2. Right? Yes. We have to simplify underneath the radical first before we can take out perfect squares. So the addition has to come first. Okay? Okay, I would like to give you a moment to find the length of segment JK. But just kidding, I really want you to do it. Sorry.
Are we doing it or not?
You are doing it.
Okay.
You are doing it.
Would square root of 4 plus 144 be the same as the square root of 4 plus the square root of 144?
It becomes positive or something, right?
Yeah.
Would the square root of 4 plus 144 be the same as the square root of 4 plus the square root of 144?
It is not. It is not. Are you getting the square root of 148? Okay.
4, yes. 42.
Okay, because you should have 2 minus 4 or 4 minus 2 squared, 9 minus negative 3 or negative 3 minus 9 squared. Regardless of how you set it up, no matter what, you get 4 plus 144 underneath the radical.
I was trying to make my square.
To what?
4 and 13.
4 times 4, 13. Okay, so if you gave me 2 radical 13, I will not be upset.
That's what I was gonna
Okay. So here's the deal. For this unit, I'm not gonna get picky about reducing radicals. I will in a later unit, but right now I'll be okay. Okay. I also like if you have a calculator and you put in the square root of 148. Whoops, that's. We could also write this is approximately 12.2, okay? But I'm really okay with you just staying here, okay? All right, so